Hi, my name's Michael Fitzgerald, and I'm one of the directors of NACS Astronomy. I'm here to tell you about the control system. So, here, if you have an observatory, or you're thinking of putting together an observatory, or you want to put one on the network, this is the video for you to get your head around what this thing even is, because it is not quite like anything else out there on the market. So you probably have a better time if you don't know anything about astronomy and you're building an observatory from scratch and have never done it before, then try to kind of match your previous experience of how you run an observatory to this one. It's quite different. Uh, so basically, the basic structure is you have your hardware, a telescope, a mount, a camera, all together, some sitting somewhere, and then you've got a computer connected to that. It's running some code. Maybe you have another one in the same roll-off roof or something, and it's running another bit of code controlling that. And then you have another computer which is controlling the dome, looking at the weather, stuff like that. In each of those computers, there's runs an agent. An agent is terribly boring and not very interesting looking. I personally think it's magical to see all this text. And if you do watch the logs, you will get to understand what's going on. It is telling you it's taking exposures, it's plate solving, it's measuring the seeing, etc. It's measuring stuff about the image, keeping it tracking along, receiving commands, etc. You can learn the ways of the console at some later date, but you don't have to. What's happening here is there is an agent running on the Windows computer, which is running the telescope. Here, this one is running a 10-inch telescope in New Mexico. Let's have a look. This one is a 17-inch, a few meters away, looking very similar. Uh, and then we have a weather system, which is in the same building, controlling the roof, looking after the weather. So you can see uh, on the actual telescope computers, it's just text. There's a lot of things going on behind the scenes. The agents are doing lots of spectacular stuff, but in the kind of fundamentals of it, it's a agent running on a console in Windows. Now, why is it we could put some bells and whistles on here, but what we're aiming for is reliability. And if you start making a GUI in Windows, you start attaching certain things to certain parts of Windows, uh, then you're adding in points of failure to the code. And the code doesn't need the GUI. As you can see, as the text is flipping by, things are happening. There doesn't need to be a graphic user interface. But obviously for a human being, you want a graphics user interface. So how do we do that? So we've got these reliable, robust codes running in the console on the Windows computers. One weather, two running the telescopes. Well, we actually run it through the web. So here we have one of the control areas. So rather than design an interface that is a single interface that everyone has to learn, our theory and philosophy is it's modular. If you don't like something, you can just flip it away. Or if you're in a different mode of doing stuff, you can get rid of some things and get rid of and add in other things. So that's the principle. And you can have different views for different observatories, whatever you like. And over time, we'll add more color schemes, more options, saving different presets, etc. It's great. But what's happening at the moment is this is the 10-inch. You can see it. We collect red photons. They're not just monophotons, but actually that's just the colorize button. So that's your traditional grayscale image. But we do a lot of stuff with outreach. So we have this colorize button so you can more clearly show to the user, oh, it's actually a color. So this is a crescent nebula. So yeah, you can see you can zoom in and out. Looks like the high res version isn't there yet. It is for this one. So you can zoom in as high res as you can. Right mouse button and you can change the brightness and contrast. This is an IP filter, so there's not going to be a lot of the nebula in there. So I think the user is getting images to get the star colors for a nebula. What's BV? It's got a bit of O3 in it probably. Oxygen 3. GP, probably the same. Blue. Oh, give me a H alpha one. That's a loom. Z. So I'm clicking back through all the images that have been taken. So this person's taking images and images and images over and over again. Ooh, now we're into the veil. S2 on the veil. So we've got some narrowband stuff in the veil. So you see, this is live as the images are coming in. So this image would have been taken, and then 10 seconds maybe later, it will pop up on the screen live from the agents that are running behind the scenes down here. So here you go. You can see here Crescent. It's doing a 3 out of 6. It's doing the sticks image stack. And behind the scenes, it's sending up the images and aligning the frames and doing all sorts of fun stuff. But let's get that out of the way for a moment. So you can see you can flick through the images of the night. So that's kind of nice. S2 is a very low throughput filter. So there's some M31. Anyway, I'm just having fun now. But you can see you can flip through all the images and you can watch them as they come in. So this one was 2340. It's 1140 there. It's 342 here. And exposure time is about 30 seconds. So, oh yeah, another one just popped in then. So you can see that was taken maybe 40 seconds ago. And it's popped in here. No crescent because I think just getting star colors. So, well, while we're here, let's go and have a look at the second telescope. That's a 10-inch, taking some narrowband stuff. This one here is a 17-inch CDK, and it looks like it's taking TIC, Test Input Catalog, some interesting exoplanet stuff. Yeah, nice. So this is just going to be very boring because it's hours long, probably looking at a star in the middle of the frame, looking for a transit. But, you can watch your images come in. Topic for another video, but you can watch the exoplanet transit build up. But I don't want to go into every feature. I want to give you the basics in this video. So, yeah, you can see the images coming in. I haven't told you how they've got those images. So both of these users, just coincidentally, are using the calendar tool. So here the person has put in their project. You drag a thing out just like a Google Calendar. This is just one of a few different ways you can use it. But this is good for hours-long things like exoplanet transits and astrophotography, which is the two things we're dealing with. So here you drag it out. It asks you a few things. There's a few types of observation you can put in. Most of the time it's a project session, and then you pick a project that you've designed to go in that slot. And it will run during that slot, just like this person's is. So how do you do that? So you go into projects here. I have a bunch of them. Don't know what any of them are, but let's just open one up. So TIC, this is on some exoplanet. And so you can go, put your name in, RA deck. You can do not just sidereal, you can do orbital elements type requests as well. A few kind of do you want it cropped? Do you want it full res? Do you want it to stack the image down? Do you want to make a color image? But here it's just saying I want 1,000 red images in a row. Or you can just ask it to click to collect forever. So it just will keep on going and fill up the color invite, change the filters, change your exposure times. It has a exposure time estimator here, so each of the telescopes once they're on the network will know their sensitivity in each filters. So if I want to look for a 14th magnitude star at 300 signal to noise, then it'll give me 120 seconds. So we've got cute little features like that. You can do mosaics, which is all very fun. So down here, this is the preview window. You can drag this around and it will change the pointing, and you can increase the size of your mosaic. There we go, 36 panel mosaic of not anything much really. Usually you do that for a large nebula or something. So if you design a project like that, and there's many more details we can go into, design it, save it. I didn't save it then. Drag it out, give it a name, put it in there, press create, and off you go. So that's one way of scheduling your telescope, putting things in the calendar. You also have helpers all over the place. Helpers at the wazoo. So calendar event planner. So if you want to look for galaxies, right, and you only want to see them when the moon's away or something, this will help you find all of the blocks of time that fit your moon conditions, your air mass requirements, you know, whatever you might need. This will help you find and book calendar events that match that. So if I have only dark, then it'll restrict my certain areas to what's available fitting those parameters. So there's helpers to build out your calendar. But if it's an exoplanet, you're just putting in one thing at a time. But, he says, having helpers everywhere, here's an exoplanner. So for every evening, so I'm changing the date up here, you can look at what exoplanets are available in the evening. Seems like there's a lot of tough ones. They're color coded by just difficulty. So here's a green one. So you've got Trez, 2.7% depth. That is pretty deep. You've got a visibility chart here. And you can press the schedule button and it'll pop it in the schedule. I'm not going to do that because I don't want to go and delete it out of the schedule. But you can see it makes submitting exoplanet observations very easy. And because it knows the sensitivity of the filter on the camera, it can give you exposure time needed. Very handy. So there's a lot of things like that. But the calendar tool is mainly for exoplanets, which take hours, and very long astrophotography observations. Cool. So it probably is important to take a moment to think about what's actually happening here. So you have that text-based stuff we see kind of churning away on the remote desktops. There's the weather one. But as you can see, we're getting new images in. They're just popping up as they come along. So images are being taken, they're being sent up. But how did it happen in the first place? So you had the calendar thing, and you put that on there. Make a calendar event. So there's a server online that orchestrates all of this together. All of the users in the system, all of the observatories, everything is on a series of servers. And so the telescope goes, all right, I've woken up. There is an amount of self-organization. It does organize all of its flats, darks, biases, plate solving, pointing models, etc. It's a very self-organizing, deterministic unit. It's not an artificial intelligence thing. It's a deterministic thing. It sorts itself all out, but then it asks the server, oh, what jobs do I have? And so these jobs can be these calendar events, which you put in. And once a calendar event is running, that's what the telescope's doing. You can use it directly. There is a real-time ability to use it. So you can click on, let me put this up for a sec. So you have the sky map here. This orange thing is the horizon of that observatory. It's up against a wall a little bit. You have the field of view of the telescope. It's at an angle a little bit. So you can click on different parts of the sky. Let's click over here where it gets a bit more interesting. And look around and find the thing that you want to observe. And over here, you've got a little window where you can tell it to go there. Give it a name, pick an exposure time, pick your filters, you know, move there, move and take. This is the most direct way of sending a message to control it. Probably the least used, actually. But it's good for testing. So if you want to move your telescope around manually, test something out, there's this very direct way of click, go there. But I'm not going to do that at the moment because it's working on a calendar thing, and it won't let me do that while something else is happening. Yep, exposure time. So you can If there's nothing happening and you're the owner admin, you can send it commands anytime. If it's one of your users that you permit to use your telescope, they'll have to book in a little block and say, I'm going to use it in real time. But you can just click and it'll send a message to the telescope. The telescope, okay, I'm going over here. Depending on how you set your telescope up, if your pointing's good enough, it will just slew there and take a picture. If you're like most program mounts, they're not perfect, so you move, plate solve, align, then take the shot. So that's a very direct way of doing it. There are so many ways of doing it. The other direct way, it's sort of like a direct queue, and in this mode, you can line up observations by lots of different people. We all by yourself, but you can line up hundreds of different observations in a queue that will get done over and over again. They'll go through the queue, and you can move things up and down the queue. There are other ways of programming the scope, such as the background survey scheduler. So there isn't one in this scope, but you can set up a survey and set preferences about which survey runs before other surveys. So you can have numerous surveys. You have a supernova survey, nebula survey, whatever you like. You can list a series of objects, and the telescope will pick objects to observe. Whether spread the observations evenly through all the targets, or just pick the best one at any given time. So you schedule it that way, all the way up to the bridge, which is a very long explanation to make. But basically, you have lots of tools here: Double Star Explorer, Open Clusters, Asteroid Parallax, Lunar Occultations. These all help you plan your observation and give you the specific tools you need for that particular observation. So as you can imagine, we're already 17 minutes in. I'm not going to start explaining each one. Let's just start with the Double Star Explorer because that's the simplest one. And I've already given an exoplanet example out on one of its telescopes. So when you're over in the bridge, this is like we were just looking at the hub. There's the thing where the pictures are coming in, and then we can drive it directly as the hub. So a hub is connected to all the telescopes, and you can go and have a look at an individual telescope. At the bridge, you're kind of looking network wide, even if you just use it for your own telescope. But it allows lots of things to happen. So if we go into Double Star Explorer here, we've got the Washington Double Star catalog. It kind of gets pulled up into the system. The latest change that there was then June the 12th. Here's all the entries. You can fiddle around and have your minimum, maximum separation, magnitudes, what's hemisphere in, and all that. You can sort things, etc. But if you're going to explore a system, once you've found your target, here isn't just an example of a tool that's specific to the double star. So here we've got the double star. It's this thing. Very, very close double because you can hardly separate them. You have your WDS information. You have your visibility curve. And then you have submit observation. So here it's already kind of pre-filled out with what you'd expect to request. It's given you a first stab. So it's got 14.5 here, and that's because the primary star is 14.5 magnitudes. And so it's put it in. But you can tweak it yourself, but it starts you off with what you might need. So that's an example. And then you submit it, and your telescope will pick up that job when it's not running a calendar event and do it when it's in the sky. And so there is this idea of a dispatch scheduler that's happening behind the scenes. When there isn't anything happening on your telescope will ask the system, is there any jobs for me? If you can set this in your observatory control, in your observatories, you can add people, your friends, as known users who can just use your telescope. You can tell them that you can only use it for 2 hours, and the system will block out, limit their use for 2 hours. And they can use this tool and put stuff into the scheduler from their computer. Then you can, if you like, we'll get into topics of other videos, you can share your network publicly. You can share your network in a private group. You can share your telescope with other telescopes and form a little network of your own. All sorts of options like that. And it's from this bridge where you navigate that networking and sharing between users and stuff, rather than on the hub, which is where we started, where you're looking directly at your telescope. It's a topic for a different video, but I just wanted to show you this is one of the methods of using a telescope on the system. So before we get too bogged down in all the stuff out there, we're really in this video focusing on the telescope observatory system and how you use it. So let's go back to our New Mexico observatories here. Here's the 10-inch, taking some pictures of the crescent, luminosity, so it's grey. What's happening here? Z, green. So yeah, very cool. So how does it know to open? Did I get up? Well, I was awake. That's the benefits of being in Melbourne. New Mexico opens up at about 11 a.m. my time. But I didn't tell it to. It knew to do it. So we have quite an extensive weather system, which comes as standard in the whole kit. So most of it is not reliant on your local weather station, but we will incorporate it if you have one. But it is a last resort. It's telling you the weather at your observatory. So if it's saying that it's raining on your weather station, it is already raining on your observatory. And if it's cloudy, then that's okay. Clouds usually, unless they're raining, don't necessarily do any harm. But basically, most of the weather system, like 95%, is not using that local weather station to the extent we have numerous observatories where the weather station has broken. I won't name particular brand names. There's a particular one. But it's broken, and they just went, oh, we'll just use the weather system anyway, because the weather station doesn't tend to be the thing that shuts the roof. The roof is already shut long time ahead of time. Maybe New Mexico being quite dry and clear is not a fine example. Although here, the red bit up the top, this is goodness of the weather. This is astonishingly bad for New Mexico, but New Mexico does have storms. But the red is midnight, and the yellow lines are sunset, sunrise. As you see, ooh, it's a bit yucky until Monday when it's green. There's a legend, and you can explore these representations a bit yourself, because you can just jump on, sign up for an account, come to one of these public observatories and have a go. We have some local weather maps. So you see this is microwave rain radar. So to the north of the observatory, there's a bit of stuff happening. To the south, there's a bit of stuff happening. It's pretty exciting. These things are storm warnings. So around the observatory, even though we're getting very good data, we are seeing some activity. Oh, look at that! There must have been a big storm coming up. You see, something's coming up here. That's probably the danger that's happening in the future. And we store all of the weather stuff on the system, so you can go back months, years. Yeah, I just turned that on. They got a new weather station now, so it's not that old. That's not a very good example. Let's go where I am. It's terrible news for me, which is winter storms, where it does make for some good weather maps. It's not actually too stormy at the moment, so maybe it won't be quite as exciting. Oh, it's going to be clear all of a sudden. Yeah, got rain across the Bass Strait. It is coming in. Okay, this isn't as... Oh, well, here we go. Tasmania is being hit by storms. I'll try and find one where there's lightning. Hang on. So handily, I just keep a bunch of things on my desktop. So here is the New Mexico site, and you can see we have this ring here. That's your danger ring. If things come in there, then it shuts up. It's about a 50-kilometer radius, I think. I can see the dot there. The dot is a lightning strike, and the age of the lightning strike is if it's white, it was recent, and if it's red, it's old. So they strike and then they age out of the map. The squares are storm warnings. The kind of this stuff is rain radar. So on this particular map, this is ground raid radar. The other map is satellite microwave rain radar. So if you have a look, you can see. There we go. I just paused it. You can see the rain coming through, and you did see some lightning there before. Let's run that again. Don't know why it takes a moment to get up. There we go. See the lightning moving. So we've got lightning, storms, rain, all sorts of things. And this observatory would have been shut up about an hour before any of this got anywhere near actually hitting the observatory. So, unfortunately, we're plagued by good weather. Who would have thought in astronomy you'd do that? But you have a weather report for the night, and it'll tell you when it hopes to open and shut the roof. It is pretty common, and one of the reasons that the weather system is so developed is because all of the sites, and some of them are at places in like New Mexico where it's clear most of the time, and California and bits of it clear most of the time. Here in Melbourne, songs are written about 4 seasons in one day, and it's true. It'll clear up and it'll be crystal clear, and because the water in the air has cleaned all the dust out of the air, it'll be crisp and the scene will be perfect for like 2 hours, and then there'll be clouds again. And so the system is really designed to deal with this variable weather stuff that most of the world has to live with. So this is for the next 24 hours, a very detailed estimate from the same weather system that decides whether to open or close the roof of what's going to happen. But it will update this every hour. So if the weather changes, it will change with it. The actual weather system polls every 5-10 minutes. Most of the data it pulls in is from numerous different sources, but it's usually a 5 or 10 minute cadence of that information coming in and it making decisions. So you see up here, Melbourne at the moment, over 90% forecast. I'm looking out the window and it is actually 9%. There's a little hole in the clouds, but it's all overcast. Weather report is negative, so it won't open. And the ground radar detected rain 29 minutes ago, which is probably about right. And then this warning will time out in 16 minutes. So anytime it detects rain, it'll keep it shut. Because when there's rain around, that's the best predictor of there being more rain. And so it holds it shut for 45 minutes until 45 minutes has passed since the last rain was detected. So if it rains again, it will reset the timer. There's other kind of things that may be relevant or not relevant to which observatory you're at, like frost, dew, snow. So if it detects snow in the evening, it's going to snow, it would actually force and shut down the whole observatory and send you an email and go, I have shut down the observatory because snow is coming. You're going to have to log in and override me because snow is probably a bad idea to open up to in the observatory. And so yeah, we have this clear sky chart-esque type thing, block colors so you can get to scan it. Once you're familiar with the color palette, you can scan the things that you're interested in. The top one is the primary one because it'll tell you when the observatory probably is going to open and shut, broadly speaking. This is different layers of clouds and fog, visibility, etc. Wind and precipitation risk and cloud risk, they're not actual forecast. It's an interesting one. It's probably the one I don't use the most. This one's microwave from space. This is ground radar from the ground with the storm warnings. And this is IR satellite clouds. So using all this weather stuff, the weather computer, which is it's sophisticated, but it's absolutely fail safe. You could run this for years and it will never crash by design. But yeah, so you have this on the computer connected to your roof, connected to your weather station, and it's just continually polling, keeping track of the weather, making decisions, and cataloging and reporting, and making those graphs and the forecast, etc., on your local computer. So if the network breaks down, uh, to it doesn't really bother the telescope so much. It's this weather system that makes the decision. It will keep on going because it has information about the weather and has the local weather station. But after about 15 minutes, it will start to go, oh, we don't have a network connection. We're going to have to wind things up. Because the fundamental thing is if some kind of crazy rainstorm is coming and there's no network connection and your observatory is a remote observatory, not near to you, and commonly half the night you're asleep, you wouldn't know anyway, uh, it will shut itself down for safety reasons. That's pretty infrequent unless you've got a terrible network connection. The usual time that network connections die is when storms are coming. So there's that too. So that's kind of like a proxy indicator for bad weather. If your net isn't working, there's probably something coming along. So that's the basic functionality of the observatory and weather code, uh, and how it interacts with the online system. The actual setup of all this we do for you. It's not something you wouldn't be able to do. It's just really fast if we do it. It takes 15-20 minutes to put it on. I know in the video we didn't go into much detail about, plane wave mounts, bisque mounts, ioptrons, cameras, focuses, whatever you like, guiding, plate solving, etc. Because to some extent it works with everything. So don't really need to go through a list of things that'll work. If it works with other software, it will definitely work with ours. And we're good at resurrecting old bits of equipment that don't work with anything else. So don't chuck that thing away before you talk to us. It will work with anything. And really this video has been showing you the interaction of the code on your computer and the web server online, just as the telescope code, the weather code, and the online code, and how that fits together into a little hub. We've been talking for 33 minutes and nearly 33 seconds, which is a lovely coincidence. But there's a much bigger story about what you can do once that's there. That's just describing the core operation of your observatory weather system interaction. Luckily, there's 2 more videos to go, so if you enjoyed wasting 33 minutes and 33 seconds of time with me, go to the next video and I'll see you there.